Now that we have seen an extremely simple first example of a minting policy, namely one that allows arbitrary minting and burning, I want to look at a somewhat more realistic example. So I copied the code into a new model called signed and want to modify this to make it somewhat more realistic. And the idea is to instead allow anybody to mint and burn, to tie minting and burning to the owner of a specified public key hash. So instead of having an unparameterized minting policy, I want to turn that into a parameterized one where the parameter is a payment pub key hash. And then the logic should be that minting and burning is only allowed if the owner of that public key hash has signed the minting or burning transaction. So let's add this parameter, so a payment pub key hash, and give it a name, let's say PKH. Now if I save that like this and load it in the REPL, I get an error because now the types don't line up anymore. For example, earlier policy was constant and now it's a function. It depends on this parameter. And it's always a good idea to try to have your code compile at all times. So don't just make many changes and then you have hundreds of errors, and then it's often very difficult to fix them afterwards. So I always try to keep the code compiling. And the way you can achieve that is by leaving holes or undefineds in the code. So pieces that you will implement later, but that at least have the correct type so that the compiler won't complain. So in our case, of course, the main business logic will be here in line 37, where we now want to say that this is only okay, minting or burning, if the owner of the first argument of this PKH signed. But we can leave that for later because the code at least is type correct. So the true there is not what we want in the end, but it will at least compile. Whereas this line, for example, as we just saw in the REPL, is no longer type correct because this is now a function. So let's try to make everything compile again first. So we have a parameter now here, PKH. So let's do the same that we did in the case of validators. So the idea there was, if you recall, to lift the argument, this PKH in our case, to Plutus core using the lift instance of payment pub key hash, and then apply at runtime the Plutus core function make policy to that lifted argument. So we can do the same now. So we need again Plutus TX apply code, and we must lift the Plutus TX lift code our argument. And this here is still not correct because this make policy is now a function. So like this. So this is exactly the same that we did in the validator case for dealing with parameters. So let me reload. So that error disappeared, but now I have other errors. And the reason is that, for example, here currency symbol is also now a function. So I need my parameter here as well. And I can fix this by simply composing. Let's see. So now I have problems in the off-chain code because I'm using cur symbol in this line and policy in that line as constant in the old code, but now of course there are functions, so I need to get a payment pub key hash that I can apply here to get the actual currency symbol and the actual policy. And maybe you might think that we need to add the payment pub key hash to these parameters, but actually that's not necessary because only people that actually have that public key hash should ever try to mint or burn. So that means the payment pub key in question will be the one belonging to the wallet running this off-chain code. And there's a function to look that up. So we can just do pkh own payment pubkey hash. So this will look up the own payment pubkey hash, and I see there's an ambiguity. So we want the contract one, the one in the contract monad. And now we can fix this because now we have our payment pubkey hash. So we have to apply it here, and we have to apply it here. So let's try again. And now it compiles. So that means the off-chain code is fixed. And the test, the emulator trace we wrote, just compiles as is. So that's good. So all that's remaining is to implement the actual logic. And in order to see whether the owner of this pubkey hash actually signed the transaction, we now do need the context. So let's replace the underscore by a name so that I have access to the context. And if we go back to the REPL and import ledger, then there is a function tx signed by that takes a tx info and a pubkey hash and returns a bool. So that looks promising, as if we can use that. So in order to get a tx info, recall there is the script context tx info function, which given the script context which we have, gives us a tx info. So maybe we can start using those two. So we want tx signed by, and now the first argument is this info, so script context tx info context. Okay, and now we need the pubkey hash. But note it's a pubkey hash and not a payment pubkey hash. So we somehow need to get to the underlying pubkey hash from our payment pubkey hash. But if we look for the definition of payment pubkey hash, then we see it's just a wrapper around a pubkey hash, and to unwrap it I can use unpayment pubkey hash. So let's do that. Unpayment pubkey hash, and let's reload. Okay, so I think we are done. So we added this parameter, the payment pubkey hash, and we replaced the trivial logic that allowed arbitrary minting and burning by this one that checks whether the transaction in question has been signed by the given pubkey hash. Okay, so now we should run the test, and we should hopefully get the same result as before, so that wallet 1 in the end has 333 tokens and wallet 2 has 444. So let's check that. Okay, that looks good. So this will be wallet 1, this will be wallet 2, and we do get the expected 333 and 444. So everything seems to work. I want, however, to point out one thing, namely, if you look closely, you see that the currency symbols of the tokens that wallet 1 and wallet 2 now have are different. And that was not the case with our first example. I mean, there the curse symbol was a constant, and both wallet 1 and wallet 2 ended up with exactly the same asset class, same currency symbol, same token name. Now the token name that we freely picked is still the same, ABC, but the currency symbol is now different. And the reason is that it's no longer a constant, it's now a function that takes the payment pubkey hash. And that, of course, is different for wallet 1 and wallet 2. So those are now two completely different coins or tokens or asset classes that the two wallets ended up with. So we have succeeded and written a somewhat more realistic minting policy that might actually be useful in practice. And somehow it's analogous to a central bank. So if you think of the US dollar or the euro, then obviously not everybody can freely mint or burn US dollars or euros, but central banks can. So the Central European Bank can mint euros or take them out of circulation, and the American Central Bank can do the same thing with the US dollar. So our example is somewhat similar to that.